Hello everyone, welcome to my channel. So in this video, let us continue our topics in the hypothesis test. So in previous two videos, I already talked about how to do the hypothesis test and also how to compute the values of our alpha, beta, and p-value. So in these videos, I want to do some specific hypothesis tests when we have some information about our population. So here what we will do is if we know the population it follows a normal distribution, and also we know the population variance, the sigma square. So now to do this hypothesis test, the step is still the first thing is we need to choose what is our hypothesis, the null hypothesis and alternative hypothesis. So for this null hypothesis and alternative hypothesis, we want to do this about our population mean. So for example, we can say the population mean is follows equal of specific value. And then we can have three different alternative hypotheses. The one is about two sides hypothesis, and the other is two one side hypothesis. So based on this one, then because our null hypothesis is about the population mean, so that means here we will choose a test statistic x bar. So this is our sample mean. However, if our population follows a normal distribution, so if you look at our videos about the normal distribution and also about the information about linear functions about several random variables, you will know our sample mean will follow also a normal distribution. The mean is still mu, however the variance will become the sigma squared divided by n. So here small n is our sample size. So now, based on our knowledge about the standard size of a normal random variable, we can rewrite this to a z value. So this is use our sample mean minus our population mean divided by the sigma over square root of n. So this will become a standard normal random variable. So because this is a standard normal random variable, we can do or compute the probability of this standard normal random variable by the table of standard normal random variable. Okay, so because we always use z to show a standard normal random variable, right? So that's why here this type of hypothesis is also be called as a z-test. So here to do a z-test, the steps is like this. The first step is still we need to decide what is our statement or say our hypothesis. So here, because the test is about a population mean for normal distribution, right? So the null hypothesis is always a mu equal a specific value. So here we denote this by mu 0. Then for the alternative hypothesis, we can choose by three types, right? So it's about the inequation, larger equation, or larger inequation, and about a smaller inequation. Okay, and then the second is to decide our test statistic. So here for this one, this is we should compute about our. So we will just plug in the value of our mu 0 to the location of mu. So now the value of our z test, this test statistic will become x bar, which is calculated by our data, minus our mu 0, the assumption of our null hypothesis, and then divided by the sigma, which is known from our question, divided by the square root of sample size. So this is our value of this, we say z0 or say this z-test statistic. And then the last step is about get a conclusion. So here for this one, it means we decided to reject our null hypothesis. We think we fail to reject it or we accept it. So for here, about the last step, I want to give more explanation about this based on our different assumption of our H1 hypothesis, the alternative hypothesis. So in the previous videos, we already say what we can do to reject our H0 hypothesis is if we compute the p-value and we find the p-value is smaller than our significance level, or say the critical level alpha, then we can reject our H0. So here, how to compute the p-value for this situation when our population mean population is a normal distribution and the variance is known. So for this one, what we can do is the first thing we can use the value of our data to compute our small z. So here, remember this is a small z. So small z is our population sample mean x bar minus our assumption the H0 value divided by the known sigma over square root of n. So by this value, what we know for a normal distribution, standard normal distribution, we know this equation is symmetric with respect to the zero value. So here, for example, if you say this is 0 for our z, so then this z0 we compute here is we will get two value. One is on the right hand side of this z0, or if it's a negative value, then it means this is on the left of our 0 origin here. Okay, so no matter it's on the right or left, because this is a two-side test, so it's by the symmetric, we will know this z0, or say negative the absolute value of z0. Okay, so this is a negative on the left and positive on the right. So we know this region will give us this, the probability of this region should equal our 1 minus p. So in other words, on the right, this is p over 2, and on the left of this region, the probability is p over 2. So based on this, and also the table of the standard normal random variable, what we will know? We will know the probability of our capital Z random variable, standard normal random variable, smaller or equal to the small z 0. Okay, I forgot the 0 for the capital Z. So capital Z 0 smaller than the small z 0. This probability should equal what? Should equal p 1 minus p over 2. Okay, so then by our notation of this CDF of our standard normal random variable, this actually the probability we can denote this by phi of small z0, right? So we know this is equal 1 minus p over 2. So based on this equation, we can get the value of our p value is equal 2 times 1 minus the CDF of our z0. So here, remember this z0 is a positive value of the absolute value of z0. It should be greater than 0. Okay, so now this is how we can compute a p-value for a two-side test. So if for the question they give us a critical region alpha, then we can compute this p-value of the critical region. If this p-value is smaller than our given alpha from the question, then we will reject our non-hypothesis H0. However, if this p-value is larger than alpha, then we can accept H0, or in other words, we fail to reject. Okay, so this is about two-side case, two-side testing. So that means our H1 will give the mu is not equal mu0. However, for the one-side test, we will similar to compute the p-value and then draw the conclusion. So when we have the alternative hypothesis is the mu greater than mu0, then based on the similar idea, we can get our p-value is equal 1 minus the CDF of a standard normal random variable at absolute value of z0. So here we also use the table of the standard normal random variable to get this value. And now if we compare this p-value with our given alpha in the question, then if this p is smaller than alpha, then we can reject the H0, the null hypothesis. However, if p-value is greater than this alpha, then what we can do is we fail to reject or we accept this H0. And then the last case is, so now for this case, if alternative hypothesis mu is smaller than mu0, then we can have our formula for the p-value is equal to CDF at the value absolutely value of z0. So now the similar is if our p-value is smaller than the given significant level or say the critical level alpha, then we should reject our null hypothesis H0. Otherwise, we will fail to reject or we accept the H0. Okay, so this is how to do the z-test, or say the test of the population mean when the population is a normal random variable and the variance of this is given. So in next videos, I will start to talk about if we try to specific the probability of the type 2 error, or say the beta value, then how we can use this requirement to decide its sample size value n we should choose. So please subscribe this channel and see you in next video.